Hey there, and welcome to another channel review where today I will show you the brand new FNIRSI DSO-TC4 component tester, oscilloscope and signal generator, among other features of this Swiss Army-like test equipment. DSO-TC4 is the fourth generation of the FNIRSI component testers, where in the last years they have getting more and more packed with features like the oscilloscopes, signal generator and others. After all these years, this device seems bigger, faster and meaner, but one thing is the looks and the other thing is the execution. What really matters is if it will continue the good legacy of the previous versions. Bear with me while I fully test it in this video and find out. Also, let me tell you that the DSO-TC4 was sent by FNIRSI free of charge for this review, and they didn't pay or had any influence on its production. And this video reflects only my independent opinion of this device. And more, they will see at the same time you will when it's published on YouTube. That said, I do have to thank FNIRSI for their care and attention by sending this unit for review. But not only. I'm able to maintain my videos independent because of your sponsorship. Yes, you, my viewer, that use the affiliate access links on the screen whenever you need to access AliExpress or Amazon to do your purchases. Just by using these links, that by the way you should bookmark on your browser, you are sponsoring the channel and helping me to produce these videos. So a big and heartfelt thank you for you. Enough chit chat, let's get this party started, as always with the key features. Allow me this small break to send kudos to this video sponsor, PCBWay. Being a leader in PCB fabrication, it is able to manufacture with very low price and in record time the PCBs for your project. Don't believe me? Just take a look. You get 10 PCBs double-sided for $5. It's hard to beat this. But that's not all. You can even create your project parts like custom case with their injection mold service or 3D printing, not to talk about their professional CNC machining service. It's a one-stop supplier for all your project needs, and if you use the code below on the screen, you will get a $5 discount on your first order. I have on the workbench the box for the DSO-TC4. Basically this is an oscilloscope, signal generator and also a transistor tester, and it has 13 waveform outputs, not bad at all. It has a new design, very well, and it comes in this normal FNIRSI retail box. One detail, right now the English part is on the left side, it used to be on the right side. And yeah, let's see what is delivered with this. Okay. As usual, we have the quality control from FNIRSI, a user manual, and the user manual is in Chinese and English, I believe. Let me see. Yes, with a very nice quality, infographics and everything else. And we have a warranty card in the end. This is new. Okay. And this device, it's a big device. It's much bigger than the previous ones. Okay. Let me see what else do we have in here. Okay. And we have a set of cables. Let's see what we have. A lot of cables. Okay, so it is delivered with the normal rings for the probe. The probe is the P6100 and this is for the common. And we have also these claw clamps, yeah, for ICs. And what else? USB Type-C to USB Type-A cable for charging and probably upgrades of the firmware. And finally, we have this MCX connector to dual alligator clips. Yeah, cable. I think I saw, yes it is. You have also an adapter from MCX to BNC, so you can use the probe. Yeah, that's nice. Well, for first impressions, I have to say that this device, as I told you when I did the unbox, is much bigger. This is the latest version of the TC devices, or DSO-TC devices, the TC3. And as you can see, it has a huge difference in size. But if it works okay, that's fine. So we have here the first generation. This one didn't have the oscilloscope yet. The second generation, the third generation, and this one is the fourth generation, the TC4. Okay, in terms of the device itself, it has some silicone keys, nice to the touch. We have in here, and let me get my pointing thingy. We have in here the input, I think, for the infrared, and obviously the probe for the ICs or the components that you want to test. Not much going on in here. On the left side, on the right side, sorry, you have, I think this is a reset button and a USB socket Type-C for charging and upgrade. On the top, let me put like this, we have an in port 0 to 40 volts, digital signal generator, and the DSO for the oscilloscope. On the back we don't have much, only this stand. It will give you, let me see if I can open it. It's not very easy to open. Okay, it will give you like 45 degrees, maybe more, 60 degrees angle. Okay, and yeah, that's it. It's a comfortable angle for working. I don't see much more here on the output to show you. I have my setup already in place with the a probe that you cannot see, but it's connected to the MCX adapter, and my function generator on the back. I will activate the channel 1, and now let's power this so we can start testing this device. Okay, English please. Nice. Whoa, very nice graphics. They are redesigned, the menu, the interface. So we have the tester, the transistor tester, the oscilloscope, signal source, toolbox, and settings. And let's start with the settings. Okay, the settings, the menu looks very well, very nice. So we have, I think, Chinese, English, Russian, don't know this one, Spanish, Portuguese, German, and Korean maybe? Japanese? I don't know. Okay, 8 language, not bad at all. We have also the volume of the bip, the screen brightness. Now it's at the maximum, no worries. Startup on boot, that's the menu when you start up. Right now you start on the menu, but you can start directly on transistor tester, oscilloscope, or signal source. Let's see what else. Auto shutdown, it's disabled, but it can be shut down automatically in 15 and 30 minutes or 1 hour, 60 minutes in this case. USB sharing, probably to take the image that you can capture, I believe, in the oscilloscope. Maybe put here the upgrades file, who knows. And the about, okay, seems nice. Okay, and we are back to the menu. And what else we have here? We have the toolbox. Okay, in the toolbox you have the voltage test. This is a toolbox more or less, it seems very the same that we had on the previous models. This is it's a voltmeter for testing voltage from 0 to 40 volts. This is the continuity test for testing Zender diodes. This is for temperature probes, the DS18B20 and DHT11. okay, the decoder from infrared signals, and what else? And the calibration. For the calibration, you have to short this with this, well, these clamps, so you can do the calibration. Okay, and that's it on the toolbox menu. Let's go back. And what else do we have? Settings. Okay, we have the transistor tester. The transistor tester don't have much to know about. You just put here your component and press auto to run. I don't have anything there, so it should give an error or nothing. Okay. One thing that it's pretty handy is that if you press mode, you change between the features. Right now you are on the oscilloscope and signal generator, and again back to the component tester. So it's pretty easy to do this. Well, since we have this button, let's go to the oscilloscope. Okay, in terms of oscilloscope, on the top you have the signal generator information. Right now it's outputting. You have also the time base, the run state, and the VH. It's information of what will happen while using this keyboard, the arrows and the, okay. And I will show you in a bit. So in the bottom we have the measurements and also the amplitudes, the trigger. Right now it's in auto with the edge. The probe is one time, and we are with AC coupling. To change these options, I believe that we do a long press on mode. Okay, and we have a menu for that. Let's see. This is the first time I see this menu. So we can change the coupling. Okay, you just go up and down. Okay. How does this work? With OK. So now I have the coupling in DC. The probe I want 10 times. The mode is normal, and this is normal. And let's go to params. So this is the measures. So you have in terms of measurements. Okay, but if right and left change to the other option, how do we? Okay. Okay, nice. And it will not go back to the... It will be nice if it does the complete circle and then go back to the first option. It will be a nice detail. But anyway, that's good enough. So we have right now the frequency, that is cycle positive, and the voltage peak to peak. This is AG. Okay, this is the persistence. We have 15 milliseconds, 1 second, and infinity. Nice. And the image, we don't have anything because we don't have any image saved yet, I believe. That's another thing. I have to see how we do save images. I will test this after in the oscilloscope part. This is just the operation. Okay, go back, go directly to the main menu. Let's see if I have anything more to see here. Okay, I don't think so. I don't know why this is, my bad. Sorry. Okay, auto, let's do it. Auto. Takes a bit. Okay. And okay, it was not well connected to the oscilloscope. Now it's okay. And it seems to work very well. It has a very nice signal, very stable. It detects the voltage 1 kilohertz and the VPP 4.76, while I have 5 in my function generator, but okay, I'll take it. Very nice. So the part that we are going to see now is the rest of the functions available with this keypad. So if you press OK, now with the right and left you are able to navigate in the buffer, in the sample memory, and up and down will change the signal position. If you press OK again, now you probably are, yes, you are able to change the trigger with up and down, and left and right still still moves the measurements. So this basically is the arrows that you are able to move. Again, OK, and you are back to this menu where you can change the amplitude or the time base. Oscilloscope, it's covered in terms of operation. Let's go to signal source. Well, in terms of signal source, I don't have yet my oscilloscope here connected to see the output, but let's try to see what we have in here. Let me try to press modes for a while to see if we have a second menu. No. Okay, left and right change the signal. So we have sine wave, square wave, sawtooth wave, and half wave, full wave, step wave. Okay, reverse step, index up, index decrease, and direct current, 3 volts, multi-audio, and sync pulse. Okay, Lorentz, and we are back to the sine wave. I believe in total it's 13 wave. I believe that in total it's 13 waveform outputs. I didn't count, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and back to sine wave. Yeah, 13 sine waves. Let me see. Okay, to change you press OK, and now you probably are able. Why do we have to press 2 times OK? Okay. So the signal generator is able to create signals up to 50 megahertz. So let's see what happens when. Okay, so this should be like this. And we are at the maximum. So in terms of amplitudes, it's not able to go over 3 volts, and the minimum is 0.1 volt. I will test the signal generator on another chapter, but at least this is how it works. Now I'm not sure how we go from here to change. Yeah, no. Okay, you press once in the power. And right now you are able to change to square wave. And now you can also change the duty cycle. Doesn't matter. Okay, so in terms of signal generator, that's it. One more thing, run or stop will activate and deactivate the signal generator. And if it's not active, if we are going to the again to the oscilloscope, it shows here in red that is not active. One cool detail is that the signal that is showing here is the signal that is being output. So right now we are with the sawtooth, and we have the sawtooth here on the top. Okay, in terms of signal generator, that's it. Let me now test the oscilloscope, and for that I will activate my function generator with a 1 kHz sine wave and see how it goes. And it seems to be pretty well, the signal. Okay. In terms of frequency, well, it's not quite the 1 kHz that I was expecting. The voltage is more or less the VPP on the 5 volts that I have here. But the frequency, it's a bit off. Really don't know why. Let me check if I use the 1 times in the probe. Okay. I have also, well, it is better now. But I also have to correct it here. Okay. Let's do an auto again. and yeah, the signal is still good, and we are again to the frequency of 5 kilohertz. So not really happy with this, but with 1 times the voltage right now, it's 5 volts VPP. That is spot on what I have here in the function generator. So that is a win at least. Okay, let's increase a bit the frequency. Let's 100 kilohertz auto. Okay, and for 100 kilohertz now we have a good reading. It's basically spot on. The voltage is 497, so also good, and the signal seems pretty good. The lines are very well drawn, so no problem there. Let me see if this interference is the probe not being well connected. It seems that, yeah, it should be because of the probe. Okay, so what I will do now is pass this to 1 megahertz. Let's see. This is a 10 megahertz oscilloscope. So at this moment with 5 volts VPP seems fairly good. Okay. And we have 1 megahertz spot on, and the voltage, it's also okay. What I will do now, it's pass the voltage to 1 volt VPP. Okay. So we can examine here the drop, and right now with 1 megahertz, it's already with 800 millivolts. So for having the real bandwidth of this, on 10 megahertz, it should be above 720 millivolts, more or less, give or take. And that's what we are going to do now. So let's go directly to 5 megahertz auto. Okay. So in 5 megahertz, we are still up than the 720 in terms of millivolts, and it's detecting 5 megahertz. So in terms of oscilloscope until now, it's okay. Pretty happy with it. The duty cycle is 50%, so we are good. Let's now take it directly to 10 megahertz. This is just to test it, because oscilloscope never should be used. You always should have 1/3 of the bandwidth for margin, but yeah, this is only testing. Right now, the voltage dropped below 700 millivolts, so not quite what we should have. Let's see with an auto. Yeah, it's not even at 700 millivolts. Let's try to decrease the signal, and okay, we are at the maximum of 50 nanoseconds. And in terms of bandwidth or frequency, sorry, I always get this wrong. In terms of frequency, we have 10 megahertz. The T-cycle is okay. The voltage is a bit over what it should be. But let's try to do something else. Not like this. Okay. And yeah, let's try to go down manually. So 9 megahertz, it's 712, 700 and yeah, around that. So this should be around 9.5, something like this. Sorry, 8.5 megahertz oscilloscope. Yeah. So this should be around the -3 dB in terms of signal, 728, more or less. And the frequency is also more or less okay, 8.6.5. The T-cycle also okay. So in terms of the real bandwidth, let's say like that, of the oscilloscope, in my opinion, it should be around the 728 millivolts. But there is something that I need to check also, because we are with the probe at 1 times. I will pass the probe for 10 times and also change here, because after or above 5 megahertz, we should use the 10 times probe. Let's see what we get in that case. So auto. Okay, and it is a little lower even, but 8 point. Okay, let's try to take this to 8 megahertz and is around 700 millivolts. So with the probe at 10 times, it's even lower the voltage. In terms of sine waves, we have it here. Let's now see a square wave. And for square waves, let's see how it handles. I will start with 1 megahertz square wave. Okay. Auto. Let's see it. Not bad at all. Yeah. I don't believe this will be very good when it reaches higher frequencies, but let's see. 5 megahertz square wave, not even. So let's diminish this manually because, yeah, I think that for square waves, 1 megahertz will be what we can have with a well, acceptable signal on the screen. In terms of voltage, it's okay. Let's see. Up to 5 megahertz, it's still over, or yeah, it's still over the 800 millivolts, but the signal on the screen, it's nothing like it should. Okay, 7, 8. This seems more like a sine wave than a square wave. My function generator is able to go up to 200 megahertz, so 8 megahertz signal is nothing. The signal itself, it's very good. So yeah. Okay, let's put it again in 1 megahertz and see other signals that we have here. So we have the square wave, the ramp. Okay. The pulse, noise, and arbitrary. Okay. For me, as I see it, this is a component tester, and the oscilloscope and signal generator are bonuses. Okay, let's move on and see the test with the signal generator. Well, for the signal generator, I have here everything set up with my Rigol DSO-924. The signal generator, it's only 50 kilohertz, sorry. And I will start by configuring that. Let's see, yeah, like this. And if you go directly to the 5, it will automatically put you at 50,000 hertz or 50 kilohertz. Okay, let's activate. This is the maximum frequency that we have here, and auto. Okay, seems a very good signal for 50 kilohertz. I'm using this here on the corner. Let me show you here on the corner. I'm using the cable that is provided with alligator clips to connect to my oscilloscope. At least at the maximum bandwidth, it's very stable. So yeah, I'm happy. I would like to have some more juice in this signal generator, but I get it. This is also for me a bonus from the device that we have here. So yeah, that's good. Very nice. Let me try to another signal. No, not like this. Okay. Now, like this, square wave. Well, the square wave, it's not perfect, but again, I'm in the maximum output of the signal generator, so it's acceptable. What else? We have the sawtooth, the half wave. Let me do an auto. Okay, not bad at all. Auto also here in the sawtooth. but yeah. And we have here the full wave. Very well. Again, this is the signal at the maximum of the frequency. The step, okay. It seems a bit rounded, so the reverse should be also. Okay, this is the index up, index down or decrease, and direct current. It's here on the 3 volts mark, so very well. What else? Multi-audio and the sync pulse. Seems very well also. Lorentz and sine wave again. What I will do now is change the frequency a bit. Let's put it in half to see the quality of the signal. If, oops, not like this. Okay, I need the 2 hands. Like this, and 25 kilohertz. Okay, sine wave at 25 kilohertz. Square wave, sawtooth, half wave. It is much better now. Full wave. The step wave still has some issues, but okay. Reverse, index up, index down, and current it's pretty good. Multi-audio, okay. Lorentz, no, sync pulse, sorry. And this is Lorentz. Okay. Another thing that it's nice to test, and for that the best way is the direct current, is to test the amplitude of the signal. Let's do like this and test the amplitude. I will start decreasing the signal. We are at 2 volts right now. Okay, it's correct. Let's go now to 1.5. It's exactly the middle of our screen. And 1 volt. Okay. And 0.1 or 100 millivolts. It seems okay also. So in terms of the output, you can go from 0.1 volt to 3 volts. If you go directly to 3, it will round it immediately. In terms of signal generator, seems okay. Okay, now it's the time to start testing some components. I have here a small assortment. I will try to be fast, and we will start with capacitor. Let's see, auto is processing, and okay. This capacitor was identified as 478 microfarads with a VLOS of 0.9% and ESR of 0.05 ohms. Let's see which capacitor it is. Okay, 470 microfarads. So it seems okay. This one, okay, this one is 1000 microfarads. Let's try see what it says. Okay, well, probably is not well connected. Let me try again. It takes a bit to get there. Okay, let's try on other pin. I hope that, yeah. I was trying to figure out if I'm using the same numbers for identification. Well, but this one seems is not being able to detect. Okay. Let's try again. Okay. Now it was able to detect. So 1.5 minifarads and VLOS of 2.1 and ESR 0.05 ohms. Okay, it took a bit to identify this one. Let's try to do this faster. Okay, and auto. Okay, processing. I think the old one is a bit faster. So this is a 10.1 microfarads capacitor with a V loss of 0.5% and a ESR of 1.55 ohms. Okay, whoops. Okay, and the last one is this small one. Let's see what we have in here. Okay, auto. Still takes a bit of time, but it should get there. No? Okay, let's try again with different socket. In the deep switch. Okay. And we have 1.11 microfarads, we lost 1.1% and a ESR of 3.02 ohms. Okay, so in terms of electrolytic, that's it. And we are going to test this one, this small guy. Okay, let's try again in a different socket. Sometimes we have to connect again. Okay, 20 picofarads. I believe that's correct, but I will have to put this in a microscope to understand that. So another thing that is able to identify is inductors. I have here one to see if it works. Let's see. Okay, it's testing. And it was, okay, we have 90.2 microhenries and 3.3 of resistance, 3.3 ohms of resistance. Very nice. I have now here two transistors. Let's try to put it here and see what we have. I think both are NPN. I'm not sure where are the others. Okay. And we have a NPM, yes, with HEF of 268, IR 2.4 milliamps, and UBE 627 millivolts. Okay, nice. Let's see the other one. Should be more or less the same. Let's see. Okay. It's also an NPM, HEF 185, IR 1.6 milliamps, and UBE 639 millivolts. Okay, nice. Correctly identified. What else? I will leave the Zender diodes for the end because we will do it on the tools part. Okay, in terms of diodes, I have here some diodes. Let's try to, okay, it's a bit large. Insert here and see what we get. 243 millivolts and a capacitance of 4 picofarads and IR 1050 nanoamps. Yeah, nanoamps. Okay. And the other one that I have here, okay. Oops, probably it's not on the correct slots. No. I put it again on the number 2 in both sides. So this is 1 and 3. Okay, let's try again. So 644 millivolts in terms of voltage, IR 12 nanoamps, and capacitance 11 picofarads. Okay, nice. Now I have here 3 normal LEDs. Let's see what it does. This should be around 2.6, I believe, if I'm not wrong. 1.9 volts. Okay, the capacitance and everything else. And I don't know if you noticed, but we have more LEDs to test. It blinks while testing. Okay, let's try again. It's blinking. The other one was more noticeable. This one is the 2.5 volts with, yeah, very nice. And this last one, this small one, let's see what we have. Blinking again. Okay, 1.8 volts. This is an infrared transmitter. Let's see if it can identify. 1.2 volts. Okay, not bad. And finally, we have some resistance to test. Let's see if it will work nicely. I believe this is 600K or something like that. Yeah, so 0.6 mega ohm. It's fine, and this should be 3.4K or something around that also. Let's try to see what we have in here. Okay, 3,439 ohms. That's nice. In terms of component testing, that's it. I think that we are good. Let's move on. To test the voltage meter that is delivered in this toolbox section, I will use my DC voltage calibrator. It will go from 0 to 9 volts, but for this it will be enough. Let's start with 1 volt. We first need to power it on. Okay, so let's start with 1 volt. So it's spot on for 1 volt, 2 volts, 3 volts, 4 volts, 5 volts, 6 volts, 7 volts, 8 volts, and 9 volts. And it has a small difference, 9.1 volts. Let's see in the 100 millivolts zone. So we have 100 millivolts. It was already detecting, always. 200, 300, 400, 5, 6, 7, 8, and 9. Okay, and 9.9 gives 10 volts. Okay, it's good enough for what is meant to have here. This has a capacity to go up to 30 volts. For testing the continuity or the on-off test, you will need to add these clamp thingies to the ZIF switch in position 1 or 2, and then you will be able to test the continuity. Okay, it will beep like a multimeter in the continuity test. It's not the fastest, and it will give some kind of indication of the resistance. A suggestion, it will be much nicer if we can use this cable also for testing the continuity, and it does not work, but it will be nice if it works here on the voltage section. And in terms of continuity, that's it. For testing the Zender diode, that is the next function here in the menu, it's not tested in the normal component tester. You need to use this KAA, so it's cathode, anode, anode. It has 2 positions. I will test in both positions, the correct and the wrong, so we can see the difference. Okay. And as soon as I put it in here, it immediately says that should be around 680. Here it is, the correct position for the Zender diode. Okay, and if I reverse it, this probably and should not work, and it doesn't. So it's working as expected. It passes energy from one side to the other and not the opposite. If it's passing the energy from both sides, it is because it's not working correctly. Okay, that's it in terms of Zender diode testing, and this voltage is correct. For the temperature testing, we have 2 components, 2 sensors, the DS18B20 or the DHT11. I don't have right now in stock this one, the DS18B20, but I have the DHT11. So let's move to the DHT11. and we should use the like 1, 2, 3, 4. This one should be okay to work. If it is okay, it will detect immediately the ground, the VDD decay, and it says that the temperature is around 29 degrees. That it isn't, because it is 23 degrees in this room, and the humidity is 37%. Okay, it seems to be working okay, only not detecting the correct temperature, but that might need some calibration, I don't know. Let's try to reverse it to see if it works better. No, it's not possible to work in that way. In the 1, 2, 3, no. And like this, also no. So the best way to work with it, it's on the last part of this if socket. Okay, let's move on then. For the infrareds, we have this option here on the toolbox that has the user code and the data code. For testing the infrared, I'm going to use these two remote commands. This one is from my Heliclive microscope, the 4K microscope that I have, and this one is from a rotary table. It has a lot of options in here, but it's from a rotary table where I shot some clips for the intros. So two remotes that I will test. Probably will work also with the remotes that I have at home, but I'm not even trying to get it. Let's try with this first one. This is the remote for the microscope. Let's see what we get. So the first button that I will press is the camera, the button to take a picture also, the menu, and OK, right, left, and power on, and up and down also. So it identifies this correctly. The user code is 00BF, and you have here the data codes below. It works really good, much better than the previous models. This one is from the rotating table. As you can see, you have here several options. Let's start from the top. Okay, also identifies a 00FF. What was this one? BF. So 00FF, and all the buttons seems to be identified correctly. Yeah, you have here the codes for everything. So this function seems much better from the previous devices. Seems to be working really well. I don't know if it will be working with every remote, but normally the remotes that are compatible with the NEC protocol will work without problems. Probably this was improved and it will support a lot more remotes. But for testing, that's it. Let's continue. So now it's teardown time. Well, it has a 1500 milliamps hour battery. Okay, we have here the board. Seems well organized. FNIRSI is doing nice work lately. The last devices are pretty good. It has a scratch here. It was me opening this hatch for the connector. And yeah, let's put this under the microscope. In the front we don't have much things. We have some ICs here that I will check out what they are. The infrared receiver in this part, and this is a ONGFA mini sub-relay. Also, we should have another one in the back, yeah. Normally we have for the oscilloscope, but some buttons, nothing much. Yeah, On the microscope, I will start with the front. We have here in the bottom of the board the IR receiver and some buttons, the menu buttons, and here on the end we have this HFD. It's an ONGFA subminiature relay. Okay, the ZIF socket, and we have a few components on the top. This is the end of the board. Let me see. Yeah, in here. Just a few components, but we have here an IC. Okay, and I will zoom in a bit so we can see it better. This is the GS8092. That is a CMOS rail-to-rail output op-amp. Okay, and in the front I think that's basically it. We have a few more components, but nothing really serious. Let's turn this around, and I will start from the top in here. We have the signal generator output in this side, the voltmeter input, and also the channel 1 input. Okay, here are really on this side we have this Cosmo, let me put it here, this Cosmo solid state relay. This is with a MOSFET output, and also again a subminiature relay from ONGFA, this HFD4. Something really curious, and we don't have a shield in here, but we have, let me try to show you, these are well, supports. We have several along this line to have a shield box in this device, but the box itself was not delivered, it's not here, but we have here the draw of the place where the shield box should be, but it was not supplied. I don't know why. It was not included, but it's prepared to have that shield box. Okay, here in the middle we have the HC, let me show you, the HC4051. This is a high performance silicon gate CMOS, basically analog multiplexer, demultiplexer. It's on reverse, but you are able to see it. And let's see, in this side we have here the connector for the battery. Let's see the zoom. And also the socket for USB Type-C connection. Okay, let's zoom in. And this one is a very common IC. It's not zooming in. Give me a second. This is the TC4056A. Let me see if I can show you this, because okay, now we are there. TC4056A. So this one is very common in this kind of devices. It's basically a linear charge IC. It's a single lithium ion battery with constant current, constant voltage linear charger, as it says in the documentation. And then we have, let me turn this around again, this 3-peak 3PA1030. And this one is also a 10-bit 15 megasamples per second CMOS analog to digital converter. It's really near this IC that is scratch. We have another one, a smaller one, scratch also. I believe that should be DECs or converters. And an old one that is always in this kind of boards is this Winbound. Let me see if I can show you. Yeah, so this Winbound, it is a 64 megabit serial flash memory that is probably used to keep the settings that is saved on the device. And just on the side we have this one that is a Pi 122U, and this one basically is a 100 kilobits dual channel digital isolator. Okay, and in this side I don't think that we have much more. We have here a connection for communication if you want to set up one. And what is this? Let me try to focus. Okay, this one is from XL Semi. It's the XL 6007 and it's a 400 kilohertz 60 volts 2 amps switching current boost DC to DC converter. Okay, so it's a regulator. Okay, and from this side I think that's it. Let me, okay, we have the 3 peak here. We pass this TP4056. This autofocus sometimes it's a bit annoying, but... And before closing, I found this one. It's the 4441 from Alpha and Omega. Basically, this one is a 60 volt P-channel MOSFET. Okay, and yeah, now that's it. Wrap-up time, and as usual by this time let's talk about the price. It is being sold at more or less 73 euros or around $80 for my tariff upgraded friends in the USA that by the time I recorded this video just got a price boost of 54% on import taxes on items from China. Probably will pass this $80 value, but this is all other issue not meant for this channel. Regarding the price itself, we are getting in the pickle zone, and let me explain what I mean. While this is a great device, even if in my opinion the real analog bandwidth is a little lower than the announced 10 MHz, it's still a great device, and generally speaking, you will be okay. The thing is, if you want a component tester only, it is for me starting to get a bit high-end price for that. If you just need a component tester, I will certainly stay with the DSO-TC4 for at almost half of the price, or the LCR P1 even cheaper. And it comes with an adapter for testing also SMD components. The good news is, and you didn't hear this from me, wink wink, that if you search well in AliExpress, you will probably find good deals for this device, a bit lower of the price that we are talking about. So this device will be useful for a professional that don't need a kick-ass oscilloscope or a signal generator, where something like this DSO-TC4 will be enough. Or for example, if you are a hobbyist. Either way, I still think there is a market for it, but a bit thinner. With a 2.8 inches display and an impressive image quality, good construction, the overall quality of the device is flawless. In terms of the oscilloscope, and as mentioned before, the only downside is if you are expecting a real 10 MHz analog bandwidth oscilloscope. But if 8 MHz is still good enough, you will be totally happy with this DSO-TC4. You have good quality waveform displayed, functions like measurements, persistence and screen save are present. The signal generator is also good. You are limited with the 50 kHz signal, but while working in the maximum, it gave acceptable results. Also, the fact that the output voltage is configurable from 0.1 to 3 volts is great. The component tester worked as expected, was able to test the components without major issues, and the identification graphics are nice to see. If I have a suggestion to make to FNIRSI, is to increase a bit the font size of the results, like for the capacitance. You have a big screen, but the thing that matters most, the values read, are a bit small on the top of the screen, but this is just a suggestion. In general, works very well. The rest of the features, like the toolbox, in general work as expected, but I want to mention that the IR decoder was able to decode even less known remotes like the ones I tested from my digital microscope or the turntable. Overall, it was a nice experience, no showstopper issues, and I'm happy with this product. If you agree with me and you are on the market for one of these component testers and this one seemed the one that you have been looking for, remember that if you want, you also can give some help to the channel and sponsor it just by using the affiliate access links on the screen or in the video description whenever you access AliExpress or Amazon to do your purchases. You will not pay a cent more, but will give the channel a really big help. From my part, you have my biggest thank you. Also, not paying a cent more is your slapping that like button to help me spread the word and make the channel grow. And if you are new here or just didn't subscribe yet, let me tell you that every week I receive new test equipment for review, and by subscribing it will help you to stay on the loop with all new equipment that hit the market. That's it for today. Thank you for your time and company, and I hope to see you in my next video. Until then, take care.